Well, good afternoon, everybody. It is an absolute pleasure to be presenting on this series of webinars, and I would like to start just by thanking Xavi and the campus for the invitation to present. Lots of topics we could have covered, but I decided today it would be useful to talk a little bit about wetting agents, and within that talk about their technologies and modes of action, with a nod to a few little bits of research that ICL have completed on the subject. So you've got my background information. I won't repeat that, just to say that I'm currently the International Technical Manager for ICL, but this presentation today is definitely not a sales pitch, and we're going to talk about the science and the technology behind our use of wetting agents in the industry. So, to start, simple statement, I think to produce truly great putting surfaces, we need to effectively manage our root zone moisture content. And this might be for Northern European golf courses where perhaps we have an excess of water at certain times of the year, or it could be in Southern European golf courses where we have a scarcity of water, and obviously we're using irrigation to manage the surfaces. Wetting agents will help us produce truly great surfaces in whatever environment, as I said, in Northern European and Southern European environment. So today I want to talk a little bit about those. We're going to cover the background of surfactants. We shall talk a little bit about the types of wetting agents that are available. We'll also cover a little bit of information about dry patch or localized dry spot, the causes and solutions we have for that. I'll talk a little bit about dew dispersants towards the end, and then hopefully we'll have time for some questions. Perhaps in all, 30 or 40 minutes, hopefully, of information for you. So, again, the beginning. Well, surfactants are a class of chemicals that cause a physical change at the surface of liquids. It's how their name is made up. They are surface active agents. So the word surfactant comes from that. I think it's important to know that there are a large number of surfactants available that can be utilized, and the range of commercial wetting agents that we have, can be formulated from a single surfactant, but more commonly formulated from one or two surfactants, and some out there on the market are formulated from a range of surfactants. And that is the difference between them, the constituent surfactants of which the wetting agent is made up. There are a number of types of surfactants that the formulation chemist can select to use. We could broadly split them up into, based on their charge, if you like, so there could be anionic, cationic, and non-ionic surfactants available. In reality, most of the commercial wetting agents, the key constituent would be the non-ionic surfactant. That's most suitable for plant applications. The reason being, a non-ionic surfactant will work well in our sports turf root zones. Generally, they are low reaction, so they don't react with components of the root zone. They are low foaming, so easy to use. And in general, if used at the appropriate rate, we would describe them as having low phytotoxicity, so no damage to the grass plant. We can continue to consider, if you like, the different categories of commercial wetting agents that might be available. I broadly, in my mind, split these down into those described as summer use wetting agents. So essentially we're using to make our water use, our irrigation effective, so we're looking for water conservation quality. And those that I would describe as winter use wetting agents, essentially those that we might use to improve water movement. So we have this initial broad separation in terms of the main wetting agents that are used. Our summer use wetting agents, the term summer use or the term water conservation is perhaps not the best term to use, and much better to describe these as residual wetting agents. Essentially, our residual wetting agents are those that we use to prevent or reduce hydrophobicity occurring on the turf. We would use these to maximize the effectiveness of the water that we're utilizing. In general, their formulation is based around a sort of block copolymer molecule. I'll come back to that in a second. Now, our winter use wetting agents, essentially we describe these as being penetrant wetting agents. Now, they're penetrants in that they get water moving. They're generally used to break hydrophobic layers, and their formulation, their constituents can be based around a number of different chemistries. But the key component for a penetrant wetting agent would be a constituent which lowers the surface tension of water. Now, there are other wetting agents out there, other classifications. One commonly used would be a dew dispersant, and we'll touch on that a little bit later. And there are some that offer a more curative action, so in an attempt to cure our root zones of hydrophobicity. And there are others, more specialized ones, we might use to move salts out of the root zone or to make better use of grey water or saline water that we're applying. So, again, a little bit more information. When we talk about surfactants, one of the key components, particularly for residual surfactants, is this molecule called a co-block polymer. Essentially, this is a name, a classification we give to a particular type of surfactant. And our co-block polymer is the main component of most of the residual wetting agents that are out on the market. It's important to say that there are many subdivisions and varieties of co-block polymers. They are essentially a long chain compound that has repeating polymers down the chain, and these repeating polymers can be hydrophobic and can be hydrophilic, so attracted to water, or if you like, put it simplicity, repelled from water. And the ability, the strength of a wetting agent, the classification often depends on the ratio of hydrophilic to hydrophobic components within this co-block polymer. You can select, as a formulation chemist, you can select, co-block polymers for a range of chain lengths, and as I said, depending on this ratio between hydrophobic and hydrophilic components, they can all have slightly different wetting properties. So, where to start? This simple picture is what it is all about. And if we look at this in detail, there is a lot to consider here. I'm going to explain this further with the help of a short video. So let me just switch my screen, and I'm going to open up a YouTube video, and hopefully you can all see this video playing. Okay, let's just see if I can move that bar out of the way. So here we have a dish of sand. The sand was collected from a golf course. It was dried and placed into the dish. And I am dripping water from the tap onto the surface of this sand. And you can see very clearly that that water is beading up onto the surface and not penetrating the sand at all. So what is happening? Why won't this water penetrate into that sand below? Well, actually there's two things going on. The first is that the water is a polar molecule, and so essentially it has high surface tension, and that high surface tension means it wants to form a droplet. The second thing happening here is that the sand is hydrophobic, so it does not let the water in. Now we can treat this sand by applying a wetting agent. And what I'm dripping onto the surface here is water and a residual wetting agent. And you can see that in contrast to our bead of water, the wetting agent has wetted the surface of the sand and sunk in. What happens now is that we can take normal water and drip that on top of our treated root zone, and that water will infiltrate as normal. So you can see that where we add water over the top of our wetting agent, it sinks into the sand, whereas non-wetting agent treated sand, the water balls up on the surface. I can repeat that with a second residual wetting agent. This is a different one, and this behaves slightly differently in that it takes a few seconds for the residual wetting agent to break the hydrophobicity, but you can see that it does sink in. Straight away here we have two different wetting agents, but they're both behaving in a similar manner in that they are breaking the hydrophobicity and they are allowing the water to move into the sand. Again, if we drip just normal water onto the surface of this treated hydrophobic sand, we can see that it sinks in, whereas where the wetting agent has not been applied, it does not sink in. So that would be our demonstration of a residual wetting agent. We can also use this example to demonstrate a penetrant wetting agent. So I'm just collecting a penetrant wetting agent here, and watch what happens if I drip a penetrant wetting agent onto this water droplet. It instantly breaks the surface tension of that water. That water is then able to penetrate the sand and move in. You know, that is really clear. So we have addressed this hydrophobicity in the sand in two different ways. We've used a residual wetting agent to wet the surface, or we've used a penetrant wetting agent to lower the surface tension and to allow that water to sink. Okay, right. I'm just going to flick back to my presentation. There we go. So hopefully that was a clear demonstration just illustrating the two different types of wetting agents I've mentioned, the residual and the penetrant wetting agents. Okay, let's go back to the presentation. You know, a simple question. Hey, what do we need wetting agents for if we're managing a golf course? Well, we've been out, I've been out and asked that question of, you know, a number of golf course managers. You know, what is your primary motivation for utilizing a golf green wetting agent. Give them a number of options to control localized dry spot. Is it to improve irrigation? Is it to improve surface playing quality? Or, you know, are they something that the golf course superintendent does not use? The results to the survey came back like this, in that golf green wetting agents were used by all the golf course managers that we questioned, and the majority of them selected a golf green wetting agent to control the development of localized dry spot. A few selected it to improve their irrigation effectiveness, and a few suggested their primary motivation was to improve the surface playing quality. So if we take these results as being true, then with a residual wetting agent, we need to ensure that it enables the golf course manager to control localized dry spot. What do we mean? Well, I'm sure most of you are very familiar with this unique turfgrass phenomenon called dry patch development. Here we have a golf green with this feathered surface, if you like, you know, this feathered area of drought stress, of turf stress on the surface that comes about from, you know, the development of dry patch. Now, if we go out onto that golf surface and we take a root zone core using a soil auger from an area on the dry patch and from an area off the dry patch, we get slightly different things happening. What we see, if we take a core from an area on dry patch development and we drip water onto the surface, just as you saw in that video, that water balls up onto the top of the core. It's an actual test you can run. It is called the water droplet penetration test, and you drip water onto the surface and you time the amount of time it takes for the droplet to sink into the core. If you have severe dry patch, then the droplet will not move into the core at all, and so that shows that you have clear hydrophobicity. So what is happening? You know, and it doesn't have to be right the way through the core. Here I've taken another sample of soil from a hydrophobic area, and towards the surface of the turf, the water would soak in naturally. But as we move down through the root zone, we actually find that the water balls up, you know, at a few centimeters away from the surface. So we have a layer of hydrophobicity building in this root zone, which will obviously cause no end of problems. Now, what is happening? We can see from these electron micrograph or photographs. Now, I have sourced these from the originals. I think came from the magazine Golf Dom in an article written by Carl Danneberg. You can see in these pictures we have an image here of a clean grain of sand and an image here of a non-wettable hydrophobic sand. What we see is that there is a build-up of organic waxy materials on the surface of this grain of sand. This is what gives the sand its hydrophobicity. It prevents the water moving down past it. And so, you know, this is what we need to prevent. And, you know, we've carried out a range of trials. I've carried out a range of trials looking into this, and I'll just demonstrate from this example. Here we have a residual wetting agent trial carried out in Spain last summer on the practice green of a golf course. A fully randomized and replicated scientific trial carried out through the summer of 2016, which was a very hot summer in this region. So we got significant drought stress and dry patch developing on that surface. And we implemented a program, a full program of residual wetting agents through the summer over that surface. And this sort of trial does generate a lot of results. There's a lot of information to present. I'm going to focus that down just to a couple of simple graphs, really. So here we have the first simple graph. This is showing the measurement of drought stress and dry patch across the surface. Okay, on this axis we have an increasing amount of drought stress and dry patch, and this line represents our untreated control. We can see we saw considerable buildup of drought stress on the surface. The high summer temperatures meant that turf was stressed and had to be carefully managed. By implementing a program of wetting agents, residual wetting agents, you can significantly reduce the impact of drought stress and dry patch on the surface in this sort of situation. And the wetting agent halves, more than halves, the amount of stress that that turf is suffering. And this is, exactly what we want to achieve. We want to alleviate the stress, reduce the dry patch developing by using a program of wetting agents. Now, when I say a program of wetting agents, what I actually mean, is a series of applications that take place through your growing season. And that can be illustrated using this figure. Now, I apologize, this figure has not been translated, so the text on it is in English, but hopefully it will make sense when I explain it. We effectively have time along the bottom axis, and we have the amount of wetting agent in the root zone of the vertical axis. And we apply, or we suggest it is good practice to apply your wetting agents in this programmed approach. So you start early in the spring and you make an application. You put your application down and that wetting agent will start to degrade in the soil. So after a bit of time, 3 or 4 weeks, you make a second application which builds the amount of surfactant in the soil, and a third application, and so on through the summer. The hope being that you build your level of wetting agent in the root zone so that when you experience your highest amount of stress, drought stress and dry patch developing at the hottest part of the year, we have built up a level of surfactant in the soil which is able to help that turf manage. This diagram is quite simplistic in a way. You could start with higher amounts and then add less as you go through the year, but it just illustrates a sort of programmed approach that is recommended from the application of a wetting agent to build up those levels of wetting agent in the turf. So that's a recommendation. My second recommendation is a simple one, and that is invest in a good quality moisture meter so that you can measure your root zone moisture regularly and understand how your moisture content changes over the surface of your root zone, changes over your golf greens, so that you can identify when stress is building and manage that appropriately. Moisture content, a moisture meter really helps you to achieve that. It allows you to, essentially record the values that you're getting, understand where the sensitive areas on your greens are, hot spots, high areas, sometimes margins around the edge, and you can add extra wetting agent into these parts. You can hand water them to keep your moisture levels higher. What we also say our residual wetting agents will do is that they reduce the drought stress that the turf suffers. Here's a very simple experiment. We have Agrostis capillaris in pots of USGA root zone. Okay, we get it growing nicely, looking healthy, and then we put those pots under drought stress by limiting the amount of water that they receive. And when we limit the amount of water, we can see that the turf becomes stressed where there's been no wetting agent applied. Where we've been applying wetting agent, we can see that there is some moisture retained, which maintains a little bit of plant health. And again, that can be described simply in a graph where we are looking at moisture content against time. Our untreated controls, we see our moisture contents drop, our turf gets stressed, and where we've applied residual wetting agent, we can retain moisture in the surface. So here you say, well, why is that happening? How is that happening? Well, again, I can illustrate with a few diagrams. Here we have a USGA root zone. It might be a little bit hydrophobic. We apply water to the surface and it beads up and sits on the surface. You can actually see how hydrophobic a surface is by measuring the contact angle of the water on the surface. And if the surface is less hydrophobic, the water will spread further, and so our water droplet becomes larger. A larger water droplet means that there is improved infiltration. The water can access a larger amount of sand grains. Where we have a hydrophobic surface, we have reduced infiltration. And that reduced infiltration means that you get something called preferential flow, in that when our water finds a route down through the root zone, generally all follows the same route. So within our root zone, we have areas that are wet and areas that are dry. And we want to use wetting agents to prevent that. So where we apply a wetting agent, we can spread the amount of water traveling through the root zone. We can spread the water within that root zone. But you will find that even where wetting agents are employed, some are better than others at allowing the water to spread through the root zone. The very best wetting agents will maximize our water penetration and maximize our flow. And some are formulated with essentially co-formulants which help that water spread through the root zone. This means that we get the most effective use of the water that we're applying. And so when our water supply drops, we have more moisture retained in the root zone for the plant to grow. This is illustrated in a range of trials. Here we have a trial just to demonstrate that not all wetting agents are the same. Okay, this is a golf green managed under hot conditions with reduced irrigation. So the trial area is under drought stress. And you can see the reaction of the surface from wetting agent 1 compared to wetting agent 2. Okay, these areas have been subjected to the same amount of stress. They've been subjected to a wetting agent program, a label rate wetting agent from wetting agent A, wetting agent B, but you can see that in this case, wetting agent B is less effective at reducing the plant stress. So, the message here is your selection of wetting agent is important. And we'll come back to that later, but it does make a difference, that some work better than others at reducing plant stress and maintaining the surface. So let's move on. The second category of wetting agents were these penetrant wetting agents, essentially answering the question, what do we do if we have excess moisture? So again, we asked the group of greenkeepers we spoke to earlier, do you use a penetrant wetting agent on your golf greens over winter? Yes, they understand but don't have the budget, they're not convinced of the benefits, or they have used in the past. This group of greenkeepers, this group of course managers, replied in the following, in that a number of them, nearly half, already use penetrant wetting agents to help move moisture through the winter. And, a number of them have used them and don't use them at present, or need to be further convinced of the benefits of these. So we'll illustrate their action in the next few slides, really. What we have with a penetrant wetting agent is a wetting agent that is designed to efficiently reduce the surface tension of the water. And you can see on this slide, here I've dripped just water onto the surface, and here I've dripped a penetrant wetting agent, and you can see that spread of the wetting agent. There are a number of different compounds that can be used to achieve this reduction in surface tension. And I would like to demonstrate that again with another short video. So I'll just drop out of my presentation and jump into the second video. Hopefully you can all see my screen, and if I click on play, we have hold on, let's just move that out of the way. So here I am dripping some water with a little bit of blue dye in onto a hydrophobic surface. Okay, you can see that the water has balled up onto the surface and formed this discrete water droplet. If we do the same thing with a residual wetting agent that has some blue dye in, same volume of water, we have a larger droplet forming. Here we have our second residual wetting agent. Same drops of water, we see a larger droplet forming, and these two are slowly spreading out. But watch what happens when we drip our penetrant wetting agent onto the same surface. Okay, this is the same volume of liquid onto our surface. Okay, so our water droplet essentially taking up 8 or 9 little squares across the diameter. Our residual, we get up to 10 or 11 squares. Our second residual, 10 or 11 squares. And here we have our penetrant wetting agent designed to lower the surface tension of water, and that is exactly what is happening. That droplet is just spreading and spreading and spreading across the surface. Clear illustration of what penetrant wetting agents are formulated to do and why they can be useful in a turf situation. So let's stop that. Let's go back to my presentation. So what that means, if I can talk you through this little example, is that you can take 2 columns of root zone from a golf green, dry them out, and you can apply the same amount of water and the same amount of a penetrant wetting agent into the surface. What you'll find is they both infiltrate into the sand, and then the water reaches a limit where it will not penetrate into the sand any further. It has reached something called its critical tension, and it won't drain down. What you do see, though, is the penetrant wetting agent with the lower surface tension continues to move that liquid down through the column. Now, if we take a moisture meter and measure the moisture content in the surface of these columns, a column with water applied has a moisture content of 30% of the surface. Essentially, the pores are filled with water. Our column with penetrant wetting agent applied has a moisture content of 5%. It's helped move that moisture down. So we can utilize that, if you like, in a golf course situation for drying out the surface of our turf. Now remember, this is a pure sand, so if we have organic matter in there, it will adjust the moisture contents a little bit further. So moving on, that would be our penetrant wetting agents. We'll also talk a little bit about dew dispersants. Essentially, a dew dispersant is a wetting agent which has been formulated with a surfactant and additional. I guess the simple way to describe them would be to have stickers and spreaders in with the surfactant. The sticker and spreader is designed to stick the dew dispersant to the leaf of the plant and spread it over that surface, so that when you get a dew forming on the surface, essentially the water won't stay on the leaf and it runs off the surface, as you can see in this trial example. Now, dew dispersants can be very useful for a number of things. They improve the dryness of the surface, so improve the quality of cut and the play on the surface. They reduce dew quickly, so as I said, the golfers can put their ball better, but they also can reduce the incidence of disease. So where you apply them, you get a drier grass blade of the turf, which reduces the disease outbreak, especially for any leaf-borne sort of fungal pathogen type diseases. And you can see what's happening in these two pictures. In this picture on the left, we have some turf which has had a dew dispersant sprayed onto it. And there is still some moisture there. These pictures were taken the morning following a very heavy dew outbreak. But essentially that leaf is fairly dry. Take 2 steps outside, same turf, okay, outside where the dew dispersant was sprayed. Just look at these leaves here. You know, they are covered in droplets of water. Essentially the dew formed on the surface, and these droplets of water make it much easier for fungal pathogens to spread over the leaf, to find roots whereby they can enter into the grass plant and start their infection points. Now, we can demonstrate this. We have demonstrated this reduction in disease in a series of trials that ICL have carried out at the Sports Turf Research Institute at the STRI in a number of years, where we've been looking at disease management and disease progression quite carefully, utilizing a range of products and surfactants to reduce disease outbreak. So in these trials, you know, essentially what we see is this. We have our time across this axis, and at this axis we have the percentage of the surface that is affected or infected by disease. And here we have our control plot. So this is the line for no dew dispersant. We can see that, you know, disease started at a low point in October and rose quite quickly through the month of October and into November to a maximum whereby we had greater than 30% of the turf surface affected by disease. That's a huge amount, and really does affect the surface. Now, just by applying a dew dispersant, we can reduce that amount of disease on the surface significantly. So these were identical plots in a replicated randomized trial, and just by utilizing a program of dew dispersants, we can halve the amount of disease that the surface sees. Okay, and this reduction in disease is significant, okay, right through this heavy disease period. Okay, I do want to say, however, you know, that let us not be mistaken in that we still see disease occurring and we only see a reduction. So, you know, a dew dispersant is not the answer to reducing disease completely. And if we had applied a fungicide at the right time, you know, definitely the level of disease with a fungicide applied would have been minimal in that situation. And so the dew dispersant just reduces that disease. But it is a useful tool to use to manage disease in an integrated system. So that would be dew dispersants. I think it's final worth saying that in hot climates where we see buildup of salt in our root zone, that can affect turf health, that surfactants can be utilized to help manage saline soil conditions or high salt root zones quite clearly. Because if you do get salt buildup in your root zone, you know, what do you need to do? You need to dissolve that salt and you need to move that salt below the level of plant rooting effectively, so you're not affecting turf health. Now, we've done some work on that area of surfactant use as well. Show you a very simple diagram. Okay, so essentially what I'm showing here is a study where we leached some saline root zones, so some root zones with high salt levels in them. We leached them with just straight water, or we leached them with an equal volume of a wetting agent that contained a penetrant and contained some calcium as well to help the exchange. And we measured the amount of salt or the amount of sodium that we removed from that root zone. And, you know, just in simple terms, you know, a penetrant wetting agent in this situation, you know, significantly removed more sodium from a saline root zone than just using water on its own. So we can utilize our wetting agents, you know, for more than, you know, efficient water use, for more than dew dispersants. We can utilize them to manage situations like saline soils as well, to reduce that salt level and that salt buildup. So I'm through to my second to last slide, actually. So in summary, I suppose, how do we get the most from our wetting agents? You know, that's what I've wanted to demonstrate through this presentation, really. The first thing I would say, you know, we've shown clearly that not all wetting agents are the same. You know, there is a wide range of wetting agents on the market. They are formulated, you know, utilizing, you know, the full variety of surfactants and co-formulants that are available. And so this means that they will have different actions in the soil. Their wettability, their ability to defend the turf surface against, you know, hydrophobicity is going to vary. So the first thing I would say would be, if you're after a wetting agent, select a quality product and ask to see supporting trial work that demonstrates the efficacy of that product. Second thing to say would be, you need to follow best practice, which would be to utilize a preventative program, which means you start early in the season. This comment is really focused on your management of dry patch development, management of drought stress, management of hydrophobicity in the root zone. There are a number of studies that show that to manage this situation effectively, you need to build up your level of wetting agent within your turf root zone. To best build up that level of wetting agent, if you start early, you follow a programmed approach, regular applications at the label recommended rate through the season. You should peak to your most amount of wetting agent in the soil when you hit your most severe weather conditions, which give you your best management situation. I would advise everybody managing turf to find some way to monitor their soil moisture contents. It helps you get a better understanding of where your turf operates to be healthy, and obviously the value depends on your situation, your turf type, your root zone type, your climate, you know, the amount of irrigation, rainfall that you're getting. But you need to monitor your moisture content so that you can appraise your wetting agent program, and so that you can identify the areas on your greens that are more prone to stress and manage those with maybe extra hand watering, hand syringing to apply water to those areas. Help you maintain your best turf quality, your best turf surface. And then don't forget, there are a range of wetting agents with different components. You know, the key wetting agent to use would be your residual through your summer to manage your hydrophobicity, but you should not forget that there are penetrants out there which can help move water when you have excess, can help you dry the turf surface out if you're looking to just dry the surface to improve praying quality. There are dew dispersants that can be used as part of an integrated disease management program to help reduce disease, and there are wetting agents that can be employed to reduce the salt content in your root zone in saline soil situations so that you can manage your turf most healthily. So that effectively was what I wanted to say about wetting agents. I'm very happy to pass on to Xavi now to open the channels. If anyone has any questions about what I have said, we can try and address those and answer any questions that might be coming.
Hello, Andy. Yes, first of all, thank you for your presentation. Really, really interesting. Yes, right now there are a couple of questions. The first one is from Antonio Pedro. He's a golf course superintendent from Portugal.
Okay.
Okay, so he's asking, how does these products degrade in the soil? Is there any risk of harmful substances built up or negative impact on the microbiome of the soil?
Yeah, that is a really nice question. We get asked that a lot. Basically, virtually all the wetting agents on the market are comprised in the most of these non-ionic co-block polymers. They're quite a complex molecule, but the constituents are very simple. And those constituents are broken down by the soil microbiology. Essentially, they see these wetting agents as a food source. So applications of wetting agent into the root zone, have some longevity, but during the course of a season are broken down by our soil microbiology. So we would not expect to see any residual components lasting, or causing any damage to soil microbiology. In fact, the opposite. They actually act as a food source, and by managing our air and water within our root zone, we are creating a healthier root zone for the development of soil microbiology.
Okay, great. Another question. Do the wetting agents perform the same way and in sun-based greens than in push-up greens with constructed on native soil with a lot of organic matter?
Okay, so the majority of residual wetting agents have been designed to combat hydrophobicity in high sand-based soils. They will do the same in more push-up soil-based golf greens, but some of them can react in a different way. So it is always good to ask about any research that is available on the different soil types. In general, they will be acting in the same way. Effectively, they will be combining with the surface of the sand grains that is hydrophobic and allowing water movement through. I have seen where you have very high organic components, so you have a lot of thatch at the surface. I have seen some wetting agents, not all, but some wetting agents increase the moisture level of that organic surface, so they don't move the water as efficiently. If you have a high organic layer at the surface, sometimes you're better off utilizing penetrants to move your water and to dry the surface out a little bit.
Okay, great. Another question. Nicolas Marin, he's a superintendent from Spain. He appreciates your presentation. He's asking if it's possible to mix the wetting agent, the dew dispersants, with other products like fungicides or foliar fertilizers.
Okay, yeah, again, a really good question. The first thing I would say is that if you are tank mixing any products together, you should always do a tank mix test. There are always going to be products in a combination that do not combine well, so you need to be wary of that. And so, you know, the first thing would be to ask the supplier of the dew dispersant how tank mixable the products are. In general, they are designed to be utilized on their own. And so, you know, be careful about tank mixing them. We have done, or ICL have done, a series of trials looking at tank mixing dew dispersants. And what we found, quite interestingly, was that they can be used in combination with contact-based fungicides quite nicely, but you do need to be careful in utilizing them with systemic fungicides, and there is potential to lower the performance of a systemic fungicide. So first and foremost, if you're using a fungicide, you know, you need to get that on before applying a dew dispersant. They can be utilized in a program, you know, in a similar manner, as long as you're careful. The second part of the question was with regards to foliar nutrients, and you know, in general, dew dispersants don't work well when the turf is growing vigorously, because a dew dispersant coats the surface of the leaf, and if the grass plant is growing vigorously, you're going to cut the dew dispersant off, so it will have a very short longevity. So for best longevity, you know, we don't really recommend you mix with a foliar fertilizer, even if you could, because the foliar fertilizer would potentially be encouraging the plant to grow, and you don't want that for the best effect of the dew dispersant.
Okay, great. The last question from Jose Manuel Rivera. He's a turf manager from Mexico, so from the other part.
Fantastic.
Yes. He's asking if there is any trouble mixing the wetting agent with reclaimed or recycled water.
In general, a non-ionic wetting agent should mix fine with reclaimed and recycled water. I would always suggest, as before, that you do some very simple tests just to make sure there isn't any problem. If your wetting agent contains any component of an anionic surfactant or a cationic surfactant, the charge on that component could slightly affect or have an interaction with the reclaimed water. So I think the clear answer is, you know, you need to be careful, but a non-ionic wetting agent should be fine.
Okay, great. Thank you very much, Andy. Let me say some words in Spanish to say goodbye to the attendees.
Of course.
And again, thank you very much.